I hope you have gone through all the curves taught till today. Because I told you that day to please go through all the derivation of the curves. Derivation in the sense drawing and explanation of the curves, how they are drawn and how the slopes are determined, how one curve is related to the other. All that has been taught, no, in traditional theory of cost. I told you to clear out everything because the topic which I'm going to teach you today, it's quite critical, and if you want to understand this diagram properly, you have to have clear idea about the past diagrams which has been taught. So with the assumption that you have gone through the diagrams and you have followed my words, I'm starting this discussion. Okay, now see, we had done till the envelope curve, the big U-shaped curve with a flatter inclination, and then it was carrying so many short run average cost or short run total cost curves. So it was something like this. Look at the diagram on your screen. It was having a look like this. So big envelope curve, into it small short run average cost curves. Today we will derive the marginal cost curve. So the discussion starts from this paragraph. Okay. The long run marginal cost is derived. If anyone wants to write, you will write from this paragraph. You will write the heading as long run marginal cost curve. Then you will start from this paragraph. The long run marginal cost is derived from the short run marginal cost curves, but does not envelop them. So here, the very first thing that comes to your mind is the picture of the short run marginal cost curves. You must remember that the shape of the short run marginal cost curve was starting from the bottom, and then it was cutting the average cost curve from the bottom, and then it was going towards the top. So that curve will have to be drawn first, and then the long run marginal cost can be derived. But just like the long run average cost curve, this long run marginal cost curve will not envelop the short run marginal cost curves. Okay, but they will be derived from them. The long run marginal cost is formed from points of intersection of the short run marginal cost curves with vertical lines to the x-axis drawn from the points of tangency of the corresponding short run average cost curves and the long run average cost curve. You look at the figure properly. This big U-shaped curve is the long run average cost curve, and the small U-shaped curves are what? They are short run average cost curves. Okay. Now at the point of tangency, from the point of tangency, you will have to tangency in the sense the point at which the short run average cost curve is touching the long run average cost curve. So from those points, you will have to draw vertical lines and stretch towards the x-axis. Okay. The long run marginal cost must be equal to the short run marginal cost for the output at which the corresponding short run average cost is tangent to the long run average cost. Now, like this, you will go on drawing the vertical lines from the points of tangency to the x-axis. First, you will draw that, and the long run marginal cost has to be drawn in such a way that it is equal to the short run marginal cost curves. There were short run marginal costs SMC1, SMC2, SMCM. This M is the point of equilibrium, so we have mentioned it as M, not as a 4. Okay, so all those marginal cost curve, this you have to think this LMC, that is a long run marginal cost curve, must be equal to the short run marginal cost curve at the point at for the output at which the corresponding short run average cost is tangent to the long run average cost. So when you will draw this long run marginal cost, no, you have to make it pass through the point at which the corresponding short run average cost was tangent to the long run average cost. This at the point of M. Do you remember? Yes, the Friday's discussion. This M was the point of equilibrium where the short run average cost was tangent to the long run average cost, and it was the minimum point of the long run average cost. So this was the point of equilibrium. So now when you will draw the long run marginal cost, that you have to make it pass through that point only, at which the equilibrium point M was achieved. Okay, at which the equilibrium point M was achieved. So you have to draw the long run marginal cost from and make it pass through that region only. All right. Sorry for the interruption. Okay, so when you will draw the long run marginal cost, you have to make it pass through that point which we had already drawn last day. Okay, the point of equilibrium was M, right? And then when you are drawing the long run marginal cost, that should pass from that point itself, M. And also at M, the SMC also should pass through. See, this M is a very, very vital point here. No, all SSC, LSC, LMC, SMC, all are meeting at this point. See, when you started with, when we started today's discussion, we started with the short run average cost curve. And then when we were drawing the short run marginal cost, we are drawing it from the bottom and then we are stretching it towards the top. That point itself, we would draw this SMCM, which will also pass through the this equilibrium point. For the previous diagram, you are drawing the SMC1, SMC2. You are not strictly following that rule, but here when you will draw that M, draw the short run marginal cost for the curve which was at equilibrium. For that point, when you will draw the SMC, that SMC should pass through this point M. Then you came to the long run marginal cost. For long run marginal cost, also when you are drawing, you have to keep in your mind that this long run marginal cost should also pass through this point M. Okay, do you see the LMC curve? It is drawn with dotted points. Dotted points is like the curve which has been drawn with the dotted points. That curve is the LMC curve. See, look at the point M carefully. Here all the curves are meeting, isn't it? This is the point where all the curves are meeting. LAC, the envelope curve, the SAC, the small U-shaped curve which are sitting on the lap of this LAC. Then we drew today the SMC curve which will also pass through this point M, and finally today we had drawn this LMC curve which is also passing through this point M. So this M is a very vital point. For levels of X to the left of tangent C, A, SAC is greater than LAC. Now see, look at the point A. What is this point A? Small a, this is the point of tangency. This is the point of tangency of this short run average cost and the long run average cost. So for all the levels of the output which is towards the left of this tangency, the short run average cost is more than the long run average cost. The short run average cost is more than the long run average cost. At the point of tangent C, the short run average cost is equal to the long run average cost. As we move from point A, from point A dash to A, so when we are moving from the point A dash, which is towards the left of the tangent C, as we are moving from this point A dash to A, we actually move from a position of inequality. We actually move from a position of inequality of short run average cost and long run average cost to a position of equality. See, when we are at the point A dash, we are not at the equality, right? Here, both the curves are not meeting each other. That means the LSC and SAC are not meeting each other. But when we are moving from this A dash to A, we are actually moving from a position of inequality to a position of equality. Hence, the change in total cost, that is the marginal cost, must be smaller for the short run curve than for the long run curve. Thus, the change in the total cost, that is the marginal cost, must be smaller for the short run curve and must be bigger, must be smaller for the short run curve than for the long run curve, the marginal cost. That is the change in the total cost. Thus, the LMC is always greater than the SMC. Thus, the change, we are talking about the change. We are not talking about the amount now. We are talking about the change, right? When we are talking about the change in the long run marginal cost, I mean the change in the long run total cost, that is denoted by long run marginal cost, will always be more than the change in the short run total cost, which is denoted by short run marginal cost to the left of A. At this portion, the change of the long run marginal cost is going to be more than A, more than the short run marginal cost. For an increase in output beyond X, for an increase in output beyond X, that is say X1 dash, say now we are at X1 dash, the short run average cost is greater than the long run average cost. That is, we move from the position A of equality of the two costs to the position B where position B where short run average cost is greater than the long run average cost. Now we are again moving to a position of inequality from the position of equality, that is A. Suppose you are moving to B, then there also the short run average cost is more than the long run average cost, isn't it? Here also the short run average cost is more than the long run average cost. Hence, the addition to total cost, that is marginal cost, must be larger for the short run curve than for the long run curve. Thus, due to this reason, due to this position of A dash and B, where the SAC is more than the LSC, the addition to the total cost must be always larger for the short run than for the long run curve. That is, the addition to the total cost, that is marginal cost, must be larger for the short run curve than for the long run curve. Thus, LMC is less than SMC now. Here at this point B, thus LMC is less than SMC to the right of A. To the left of A, LMC is greater than SMC, but to the right of A, LMC is less than the SMC. Always remember, we are not going by the situation of the graphs. We are talking about the change. When we are talking about MC, that is marginal cost, we are talking about the change. Now, since to the left of A, LMC is greater than SMC, and to the right of A, LMC is less than SMC, it follows that at A, LMC minus SMC, that at A, LMC minus SMC, it is going to be a positive value because LMC is more than SMC to the left of A. If we draw a vertical line from A to the x-axis, the point at which it intersects the SMC is a point of the LMC. Obviously, from the tangent, if we draw, the point at the SMC is also a point at the LMC. If we repeat this procedure for all points of tangency of short run average cost and long run average cost curves to the left of the minimum point of the long run average cost, minimum point of long run average. Now we are talking about this point M. Okay. Now we are talking about this point M, the point of equilibrium. Say, where was I? Okay. If we draw a vertical line from A to the x-axis, the point at which it intersects the SMC is a point of the LMC. This vertical line, no, if you're drawing the vertical line from A, when you're drawing it, it is intersecting the LMC, no? It is intersecting the LMC. So if we draw this vertical line from A to the x-axis, the point at which it intersects the SMC, when this vertical line is intersecting the SMC, this at the point at which it intersects, that is the point A for SSC. Point A, capital A, it's not shown. Okay, anyways, this follow the vertical line drawn from the point A, and it is touching the x-axis, right? When it was going towards the x-axis, it has met this SMC at a point. This the point is also of the LMC. This is the point at which is intersecting the SMC, and this is also a point which is intersecting the LMC, isn't it? This point of tangency. So see, when you're drawing this line, no, this point A is coming from where? It is coming from the tangency of this small U shape and the big U shape curve. So when you will draw this tangent, draw this perpendicular, then it should go through the meeting point of the SMC and LMC. It's not a very easy diagram, okay? When you will draw, you will understand. I don't know how many of you are drawing. Tomorrow I will see your copy. You will share the screen and show me this diagram, okay? Tomorrow at the beginning of the class itself, I will see your diagram, which this one you will have to draw. In every small U-shaped curve, when you are drawing this perpendicular, it should pass from the intersecting point of SMC and LMC both. Okay, then only the diagram is going to make some reason. If we repeat this procedure for all the points of tangency of short run average cost and long run average cost curves to the left of the minimum point of the LAC, we obtain points of intersection of the LMC which lies below the LAC. Now what we will do is, when we will write the answer for this, no, we'll first draw the diagram and then we'll explain. But this dotted line should not have been there till now. Till our discussion, this dotted line should not have been there. But for making the entire process easy, first we will draw the diagram and then we'll explain. But this is how it has been derived. Okay, if we repeat this process again and again for all the small U-shaped curves, we obtain points of the section of the long run marginal cost which lies below the LAC. At the minimum point M, the LMC intersects the LAC, and to the right of this minimum point, the LMC lies above the LAC curve. See, look at this dotted line again. Till the point M, it was lying below LAC or not? LMC is lying below LAC. But soon this point is crossed, it is lying above LAC. I'm talking about this dotted line. Till the point M, it will lie below the LAC, but after this point, it will lie above LAC. So you will draw this diagram. Figure 4.14, you will have to draw in your copy, and tomorrow I'll take randomly 10 copies and ask you to share your screen, and then I will see. How have you drawn the diagram? Okay. Now this is the thing which I was telling. I told you already at the point M we have short run average cost equals to short run marginal cost equals to long run average cost equals to long run marginal cost. Okay. This is the fact. When you combinedly draw short run and long run curves, this is the fact. Okay. Short at the point of equilibrium, that means at the lowest point of the envelope curve, all the curves, that is LSE, LMC, SAC, SMC, all of them are equal at this point. This is the best point for a plant. This is the best point in the sense all the cost will be minimum and the optimum level of output can be obtained here at this point. Understood? I don't know. I'm talking to the laptop, I think. Anyways, so your homework is you will draw this diagram. Tomorrow, I will check randomly 10 copies. Time will not permit me to check all your copies, but I will randomly ask 10 of you to show your diagram in the screen. You will share the screen. What will you do? You will take a picture of your diagram. Okay, then you will share it on your screen. If you're using a laptop, then you will take the picture, send it somewhere, send it to any WhatsApp number or any email ID which is opened in your laptop. Then you will download that photo in your laptop and share the screen in Google Meet. Okay, understood? Tell me yes, ma'am. At least tell me yes, ma'am, understood. Okay,
Yes,
very
ma'am.
good. Very good. So tomorrow I want to see this diagram, this final diagram that you have derived and description. Are you learning them? Please learn them properly. Okay. All the diagrams, descriptions in the traditional cost theory. Please learn all of them. Tomorrow we move on to the modern theory of cost. Okay. Now please respond. Abhay Sharma,
Present, ma'am. Present, ma'am.
Aditya Alsaba, Aman Goel, Aman Sharma, Ananta, Angela,
Present, ma'am.
Anish, Anisha,
Present, ma'am.
Ankit, Anmol Gupta,
Yes, ma'am.
Anmol Lama, Bhavesh, Bikash,
Present, ma'am. Present, ma'am.
Vishwadeep, Charu,
Present, ma'am.
Chirag, Deepika, Sarthak, Girish, Himani,
Present, ma'am.
Jaya, Kashish,
Present,
Meghna,
ma'am.
Present, ma'am.
Mehul, Parveen,
Present, ma'am.
Muskan Agarwal, 21,
Present, ma'am.
Muskan Agarwal, 59,
Present, ma'am.
uh, Neha Shanghai, Nikhil,
Present, ma'am.
Present, ma'am.
Nishita, Nupur,
Present, ma'am.
Piyush,
Present, ma'am.
Pragati, Prageshwar, Prashant, Pratham, Preeti, Poonam, Ronak,
Yes, ma'am.
Yes, ma'am.
Ravi,
Present, ma'am.
Riyant, Riya, Rohan, Ronak Agarwal, Sahil, Shama,
Present, ma'am.
Srishti,
Yes, ma'am.
Sneha,
Yes, ma'am.
Srishti Tamang,
Present, ma'am.
Saurav Agarwal, Suhana, Sujit,
Present, ma'am.
Suvneet,
Present, ma'am.
Swati,
Present, miss.
Swayam,
Present, ma'am.
Anya,
Present, ma'am.
Yash, Yashika, Shreya.
Yes, ma'am.
Okay.
Ma'am, you missed
Yes,
out my name, Saurav Sarkar.
I have given you mark. Okay.
Oh, okay, ma'am. Thank you, miss.
Okay.
Thank you, ma'am.
Thank you. See you tomorrow. Bye bye.